Okay, greetings all. We are looking at problem 4 from lesson 4-5. It says using a quadratic equation competition. From the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras County in 1865, frog jumping competitions have been growing in popularity. The graph shows a function modeling the height of one frog's jump, where x is the distance in feet from the jump start. How far did the frog jump? The height of the frog is 0 at the start and end of jump. So here we have, this is where he starts and this is where he ends. So it's the place where the quadratic, basically, as you can see, it's parabola in shape, so it's a quadratic function. It's the place where the quadratic crosses the x-axis. So these are the zeros or the solutions of my function. So we need to find the zeros. So using a graphing calculator to find the zeros of the related function. So we're going to use a graphing calculator because this looks like a really nasty thing to find the zeros of. So I'm going to put it in my free graphing calculator from Desmos.com, www.desmos.com. Here it is. As you can see, we can't really see it that well. So I'm going to move it over just a little bit. And I'm going to just zoom out just a little bit. Okay, there I have it. And I can see that this is the start. And here is my ending point. My ending point is at 20.345. That's how far the frog jumped. And that was in, let's see, feet. So it's in feet. So it says the frog jumped about 20.34 feet. So it says, how high did the frog jump? And the height is the top of my parabola. It's the tip. So let's look back at my graph here. So here's the height. And it has it already. Oh, no. Yep, that is the height. My height is at, or the vertex of my parabola is the maximum height. And it is at 3.001. And they have it at 3. So 3.001 is really, really close. And they have it rounded here at 3. And it says find the x value. We don't have to do that because our calculator did it for us already. It's at 10.172. So they have 10.17. So they're rounding to the nearest hundreds. Okay. So the frog jumped at a height at about 3. And the x is 10.17. All right, so it says, what is a reasonable domain and range for such a frog jumping function? So the domain is my x-axis. So I know I can't go in the negative direction, right? So the unreasonable range would be probably from 0, they said, to about 30. So a frog could probably jump about 30. And then the range, how high it could jump, that's, again, we can't go in the negative direction. So it'd be from 0. So 3, maybe about 5. I don't know. I don't know how high a dog. Oh, they said 5 as well. So from 0 to 5, from 0 to 3 for my domain. All right, so let's look at guided number 4. So as the function y equals negative 0.03x squared plus 1.60x models the path of a kicked soccer ball. The height y and the distance is x. And the units are meters. How far does the soccer ball travel? How high does the soccer ball travel? Describe the reasonable domain and range for the function. All right, so let's look at our graph. I already put it in to save time. So I'm going to turn this one off, turn this one on. I need to zoom out a little bit more. Oh, there we go. And so here, this is my soccer ball's path. It's going to shoot from start, kicks up here until right here. So this is, all of this is in meters, and I know that this is how far my soccer ball goes. And so my soccer ball travels 53.33 meters. Okay. The height of it, is in y, will be my y, which is 21.33. So remember, y represents my height. So the height of the soccer ball is 21.33. Let's look back at what the other questions were. It says, how far does it go? We answered that question. We said that it travels 53.33. And we said, and it asked us meters. How high does the soccer ball go? The soccer ball travels a height of 21.33 meters. All right, and then it says describe a reasonable domain and range. So the domain is the x-axis. So a domain would be probably from 0 to, let's see, this is 50, I'd say probably 60, maybe 65. From 0 to 60, 65. And so the range will be y-axis. So it can't be in the negative direction. We don't want to kick the ball under. So it would be from 0 maybe to 30 or 25, somewhere around there. I hope this helps with using the calculator.